Hello viewers, welcome back to our YouTube channel. In today's video, we are going to solve another question on binary operation. So the question says that a binary operation dot on the set R of real numbers is defined by m dot n is equal to m plus n minus 2. So the rule that was given for the operation dot is m plus n minus 2. And we should show that dot is associative. So we are supposed to show if dot is associative and also show if it is commutative. So let's tackle the A first. So we were given that m dot n is equal to m plus n minus 2. So to show that it is associative, we need to include a new variable, a new element. So for associative, we say that m dot n or dot p should be the same as m dot n dot p. So now we are going to tackle the first one first. We are going to do m dot n or this dot p. Now we know m dot n to be m plus n minus 2. So all this one dot p. So if you put this into the rule we are given, now our m is everything here and our n is p. So we are going to get m plus n minus 2, which is our m plus our n, which is p here now, then minus 2. So from this, we are going to get m plus n plus p minus 4. So if we do the m dot n or dot p, we are getting m plus n plus p minus 4. So now let's do for m dot n dot p. So first of all, we have to do n dot p, and n dot p is equal to n plus p minus 2. So it means that here we are going to get m dot n plus p minus 2. So if you come and put this into the rule, now our m is m and our n is n plus p minus 2. So we'll end up getting m plus our n, which is now n plus p minus 2, all this minus 2. So from here we are getting m plus n plus p minus 4. So since this and this are the same, then it means that we can conclude that it is associative, because when we did m dot n or dot p and when we did n dot p or dot m, we are getting the same results, then we say that it is associative. So now let's check if it is also commutative. So to check if it is commutative, the question says that m dot n is equal to m plus n minus 2. So now let's change the order and see if you are going to get the same result. Now here, if you change the order, you are going to get n dot m, which will give us n plus m minus 2. Now m plus n is the same as m plus n, and the minus 2, if you do, since you are getting the same result, if you subtract 2 from it, you are going to get the same thing. So now it means that this and this are the same. So we say that the operation dot is commutative. So the operation dot is commutative. So now the next question says that we should find it says that we should find the identity element, the inverse element, and the inverse of 3. So we are going to find the identity element. So from the identity element, we learned that if you have a dot e, it should give you, so whenever you perform an operation on the identity element, so a dot e should give you a. So whenever you perform an operation on the identity element in any other element, you are supposed to get the element itself. So A dot E should give you A. So here we are, in place of our N, we are going to put E there. And using the rule, we are saying that M dot N is equal to M plus N minus 2. So it means here we are going to get M plus E minus 2, which should give us the element M back. So our main aim is to find E. So we are going to get M plus E minus 2 is equal to M. If you bring this M to the other side, we are going to get E minus 2 is equal to, now M minus M is 0. So E minus 2 is going to be 0. So it means that E is going to be 2. So our identity element for the dot is 2. So now we are also going to find the inverse element. So to find the inverse element too, we said that if you have, let me move on to the next page. To find the inverse element, we say that M dot M inverse should give us the identity element. So now we've gotten our E to be 2, and our rule says that M dot N is equal to M plus N minus 2. So it means here we are going to get, so M dot M inverse of M, we are going to get M plus M inverse minus 2, which is going to give us 2. So M plus M inverse minus 2, which is going to give us 2. So M plus M inverse is going, minus 2 is equal to 2. So our main aim is to find M inverse. So we are going to get M inverse to be equal to 2. Now this 2 comes here to become plus 2, then M will come here and become minus M. So our M inverse is going to be 4 minus M. So M can be any real number. So we are just finding the general inverse of any real number. So we are getting our inverse to be 4 minus M. And the next one says that we should find the inverse of 3. So it means that in place of M, we are going to put 3 there. So wherever we see M, we are going to put 3 there. So the inverse of 3 is going to be 4 minus 3, because the inverse, we have 4 minus M. So 4 minus 3 is going to give us 1. So the inverse of 3 is going to give us 1. Yes. So that will be it for today. Thank you for watching, and please, if you have any questions or comments, you can let us know in the comment section. Bye. See you in the next video.